right? And then we know in the first quadrant, everything's going to be positive, right? Everything is going to be positive in this quadrant. So let's go ahead and use our symmetry again to help us out here. So this angle right here is going to match up perfectly with this angle. They're going to have the exact same reference angle of 30 degrees. So I'm going to take the same values and I'm just going to make them both negative. So let me zoom in here. These were the values negative, radical 3 over 2, and 1/2. All right? And it makes sense because we go left and then we go down to get to that value. All right. So now we go to the next one. So the next guy, I'm going to take this and I'm going to just reflect it straight down, right? It's going to match up with that angle. So these are the radical 2 guys. So this is going to be negative radical 2 over 2 and then negative radical 2 over 2. Perfect. Let me make that negative stand out just a little bit more. All right, perfect. So let's go to the last angle in this quadrant. This is going to be the purple guy. So my purple, this one is going to reflect straight down, and it's going to match up with that angle. So just going to take that. So 1/2 and radical 3 over 2. So negative 1/2 and negative radical 3 over 2. Perfect. And, you know, we can reflect any way we want. I'm choosing to reflect from the second to the third quadrant, and then I'm also going to reflect the first to the third, but I'm sorry, the first to the fourth, but you can do it however you want. Same thing here. Let's go ahead. I'm going to reflect this angle straight down, so this one's going to go here. So this is now going to become radical 3 over 2 and 1/2. So radical 3 over 2, comma, 1/2, and in this quadrant, my y values are negative. So that's that point right here. The next point is going to be my red angle. So this angle is going to correspond and reflect to that one. So now that's going to become, is that my radical 2 over 2 guy? Yep. So this is my radical 2 over 2. So this is the point radical 2 over 2, comma, radical 2 over 2, and the y values are negative in this case. And then the last one, we got our purple guy. Going to go ahead and reflect that one straight down, and we end up getting, I'm going to erase this really quick, and we're going to get 1/2 and radical 3 over 2. So this is going to become 1/2 and radical 3 over 2, but my y values are all negative in this quadrant. All right, and we are all done, guys. We have all the coordinate values for the unit circle. Nice job. All right, everybody, so on this slide, what I want to do is I want to put all of the angles in radians and degrees for both the unit circle cut into 8 sections and 12 sections, and I want to include all of the points where the angle measures intersect the unit circle. So I'm going to go through kind of a few little tricks or little strategies to kind of help me figure this out. So we're going to first start with our angles in degrees. So I'm going to start with 0 here on the standard, on the here on the initial side. Then I'm going to go to the next angle, which we know if we cut it into 12 sections is 30. We know when we cut it into 8 sections, this was going to be 45. You know when we cut this one into 12, this was 60, and then this one's going to be 90. So one strategy that I see a lot of students using is they will say, okay, well the distance from here to here is 30, the distance from here to here is 15, here it's 15, and then here it's 30, right? So if you look at the angle measurement, the bigger angle measurement is 30, and the smaller one's always going to be 15. So I see students using this pretty often. So from here to here, this will be your 30. So I'm going to add 90 plus 30. You know that's going to give me 120 degrees, right? Let's put degrees on all of these. Then short side is going to be 15, so I add 15, so 135. I add another 15, so that gives me 150. And then I add another 30 because it's a longer piece of angle, so that gives me 180. And we can continue determining our angles this way. So 30, 15, 15, 30, right? So 30, so that's 210. Sorry, I wanted to put an angle here. Then plus 15, so that's 225. Then plus another 15, that's 240. Then plus 30, 270. Then again, 30, 15, 15, 30. So add another 30, I get 300. Add another 30, I get sorry, I should have added 15 there. So 315. And then plus another 15, that's 330. And then add another 30, and I get 360. There we go. So that's our strategy for our angles. What about for radians, right? Radians are the trickiest ones to remember. So one strategy is we can just memorize our first quadrant, right? We can memorize our first quadrant here. All right, we're going to start at 0 radians. We know that this is going to be pi over 6. So again, I'm memorizing my first quadrant, pi over 4, pi over 3, and then pi over 2. Now, this is an extra strategy on top of also understanding that these are broken up into 8 and 12 sections. So you can also do it the way we derived it, right? This is 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6. And you can keep going, right? This is 4 pi over 6. This is 5 pi over 6. Right? You can keep going that way if you want, and that's fine. But I've already shown you that way. I wanted to show you another strategy on how to do it. So if we memorize the first quadrant, one thing that we can use is that idea of symmetry, right? The pi over 6s, the pi over 4s, the pi over 3s, they're going to repeat in every quadrant. So even in this quadrant, I'm going to use my reflection property, right, there to there. This is also going to be an angle in terms of pi over 3. Using reflection with this guy and this guy, this angle right here is going to be pi over 4. And then this one will be pi over 6. Okay, now we know for sure it's not just these angles. It's not just these values, right? And of course we know this is going to be pi. So one strategy is that all the values that are less than pi are exactly like, well, everything before pi is going to be less than pi, right? So everything's going to be 1 less. So if you look at this one, 5 is 1 less than 6. 3 is 1 less than 4. And this one, 2 is 1 less than 3. And we can apply that exact same thing in the third and fourth quadrant. So we can use our symmetry, right? 5 pi goes with this angle over here. So we know this is going to be a pi over 6 guy. Let me move that up a little bit. So pi over 6. I know this angle is going to have to be my pi over 4. This one's going to have to be pi over 3. And then this one, of course, is pi over 2. All right, so notice how it repeats in every quadrant. Pi over 6, pi over 4, pi over 3. So now all the angles, all the radian angles here are 1 unit. These are all greater than pi. So everything's going to be 1 bigger than pi. So 7 is greater than 6, 5 is greater than 4, and 4 is greater than 3. And in the pi over 2, 3 is greater than 2. Same idea in the last quadrant. Here, everything is going to be less than 2 pi, right? We know 1 full revolution around the circle in radians is 2 pi. So then I'm going to, everything's going to be less than double, right? So this is going to be, what does this one match up with? This one matches up with pi over 6. So this is going to give me, well, what's double of 6? Double of 6 is 12. 1 less than 12? 11. The next one is going to be pi over 4. What's double of 4 is 8. 1 less than 8 is 7. This one is going to be the pi over 3 one. Double of 3 is 6. 1 less than 6 is 5. So now that we have all of the angles in degrees and radians listed, let's go ahead and find a strategy to help us identify the points. So you have to know the quadrantal points, right? We know that this is going to be the point 1, 0. This one's 0, 1. This quadrantal is -1, 0, and the one below here is 0, -1. So now that we know the quadrantal, the tricky part is going to be to identify the points where the angles intersect the unit circle for each for in between the quadrantal angles, right? So I want to go ahead and let's start with this one. So I we already went over it. You can use your special right triangles every time, but we can also use a little trick. The trick is we can start at 1 up here, and we're going to count all the way to 3. 1, 2, 3. Then I'm going to start at 1 here and go up 1, 2, 3. Then I can divide everything by 2. And then I can put square roots on everything except for the 1. Because I can square root the 1, but square root of 1 is just 1. So now that we know everything in the first quadrant, now we can use symmetry to help us apply those to every other quadrant. So this angle right here in the first quadrant, I can reflect it, right? I can reflect it to the other side, whoops, and it'll match up exactly with this angle right here. And this makes sense because this measurement right here is equal to 30 degrees, right? This is 30 degrees. The measurement between the x-axis and this angle is also 30 degrees. So that's where reference angles comes into play, right? The reference angles of every angle is going to give you the exact same triangle. So let's go ahead and use my little symmetry here. Let's go ahead and use our symmetry here. So this angle is going to be rewritten right here. Or sorry, this point is going to be rewritten right there. So now radical 3 over 2 and 1/2, this is now going to become radical 3 over 2 and 1/2. Perfect.
So now that we've already seen reflecting this, so I'm just going to go through it really quickly, just kind of speed it up a little bit and just show you guys again how I just reflect from one angle to the other. So one common thing is looking at radians. Notice how the denominators have the exact same value, right? 2 pi over 3 goes with pi over 3. Now that we have the second quadrant complete, we can go ahead and do the exact same thing to the third quadrant. So pi over 3 goes, 2 pi over 3 goes with 4 pi over 3. 3 pi over 4 is going to go with 5 pi over 4. Oh, sorry about that. So those two are going to match up. They're both radical 2 over 2. And then the 5 pi over 6 is going to go with my 7 pi over 6. So those values are exactly the same. So radical 3 over 2 and 1/2. And you can choose whether to do the third and the fourth quadrant, but I like doing the first and the fourth quadrant. So pi over 6 is going to go with 11 pi over 6. Right? We've got pi over 4 is going to go with 7 pi over 4. And then we've lastly got pi over 3 is going to go with 5 pi over 3. Perfect. And the last thing is that we have all of our values correct, but now we need to get the, sorry, I'm not sure what happened there, but now we just need to get the sign. So in the first quadrant, we know it's positive, positive. The second, we know all the x values are negative. In my third quadrant, all x and y are both negative, so I'm going to give my x and y values negatives. And then in the fourth quadrant, my x values are positive and my y values are negative. So I give all my y values a negative, and we're all done.